Hey guys, today I'm going to talk about change of basis in linear algebra. Let's say I have some vector and its components are 5 and 2. Well, this basis is in basis of our unit vectors I and j. And I is just 1, 0, and j would be 0, 1. The vectors I and j stacked on top of each other give us this matrix 1, 0, 0, 1. And if we multiply it by x and y, let's say we get our vector b. All this means is that our x would be equal to 5 and our y would be equal to 2. And this identity matrix that is made by our basis vectors here, it provides no change in v because this is the standard basis. But let's say I didn't want to express v in terms of our unit vectors. Let's say I wanted to express it with our vector a, which would be, let's say, 1, 2, and I want our vector b to be negative 1, 1. Well, now let's stack these two vectors on top of each other. We'd get 1, 2, negative 1, 1, and then we're solving for our new xy, and then this should be equal to 5, 2. So now when we solve for v, our xy will be our vector v, but in terms of the basis a and b. So let's solve this over here. So let's just keep the first row the same for now and put a 0 in this spot. All we have to do is add row 1 and 2 to each other. So we get 0, 3, 7. And then next, let's divide the second row by 3 to simplify that into a 1. Now we're getting fractions over here. And then now we keep our second row the same, but we multiply this by 2 and subtract. So this stays a 1, but then 1 times 2, minus 2 is 0. And then 7 thirds times 2, well, that's 14 thirds. And if we subtract that by 5, well, that's the same thing as 15 thirds minus 14 thirds, which leaves us with 1 third. So our v, which was 5, 2, if you look up here, if we put that in our basis a and b, our new v, let's say VA, VAB or something, well, that's equal to 1 third and 5 thirds. And the reason we do this is because some equations are easier to solve when you put them in a different basis rather than in the standard basis. I hope this was helpful, and I'll see you in the next video.